show data projector and are sitting in front of the screen watching you.
Okay.
So, to introduce you, Dr. Imed Zitouni, the Tunisian researcher that works with the EEMA in Canada, I think, right?
In
New York. So he has done a good research in Arabic natural language processing, and I'm amazed of even their small teams. They are doing amazing things there. So we would like to hear about that. I believe that Dr. Imed tried to also to your history, where you studied, and what
okay.
your research interest in PhD and after.
Okay.
So I will leave you the microphone now.
Okay. مرحبا يا جماعة. Let's make it interactive. If you have a question, do not hesitate. I'll be very happy to answer any question you have. About me, I'll talk a little bit about my history. Actually, I am born in Tunisia. I graduated my engineering degree in computer science in '94, and decided to go and to pursue a PhD in computer science in France, in Nancy, and I did work on speech recognition. At that, in '95, we don't talk about automatic speech recognition like today. So I did build the first French automatic speech recognition, automatique and informatique. After that, I got graduated in what is the important event that is happening today in Ramallah.
Okay.
Interesting. You see the presentation and the video? No. If I
you are on slide number 2, I guess.
Okay. Because I'm not sharing everything, I wanted to share. I want to share more than my slides. Actually, I am sharing my desktop. So what? Do you see this directory where you have these files, including the demo 14 and the Tails demo 13?
It's appearing.
Only the presentation.
It was appearing a minute ago, but now we only see the media player.
See the content of the media player?
No, it's
no.
a black screen.
See your presentation right now. One. Now we see the directory, right?
Okay. There is a difference. So I'll wait until you see the first slide anyway of my talk.
Yes. Now we see the first slide.
Is the first slide? Good. As I said before, we are doing statistical information extraction here in the group. Anyway, it's a team of 10 people, roughly speaking. We do have contractors. We do many things. We don't only do Arabic. And this is one of the projects we did work on the last 4 or 5 years. The outline here, I wanted to show you a demo of Tails, which is a system that we built. So at least you see that in real life. Unfortunately, it's not happening, but we'll try later on after the talk if we have time. Once I talk about Tail, the infrastructure, how we build that system, then I will focus in one component of Tail, which is how to detect person names, organization name, facility names in a text. and to show how sometimes two different languages, we can use one language to help the performance in another language. And here I will show how, because there is many more resources in English, I will show how we use English to improve Arabic entity recognition and co-reference resolution. I'll describe the two applications, what I mean by mesh detection and co-reference resolution later. What is Tails? Tails is an end-to-end system that allows user to search, watch, and monitor live foreign language new media using English closed caption and speech. What I mean by that? Let's imagine that you are an English speaker. You understand English. You don't know any other language, and this is very often in this country. We're curious to know what's happening in the media in a different country, in a media that they speak languages we don't speak. And there, if we take a specific example, Arabic. Okay, so an English person wants to watch Arabiya. And he doesn't want to only watch Al-Arabiya. Actually, he's interested on a very specific event in Arabiya channel. How we do that? Do that with Tail. Actually, I wanted to show the demo, but the demo shows how Arabic channel with Al-Arabiya, we take that speech, we translate it automatically. We translate that speech into text. So we have now English text. We take the Arabic text. Sorry, take the Arabic text, and we run. We define the names in that Arabic text. We find what is per name, what is an organization name, what is a location, what is a facility. We find all this stuff. As we find those, then we translate that text from Arabic to English. And we have now we have English text that correspond to what is spoken in Arabic. And we take that English text and we do text to speech, and we make it speak again. So, and all this in real time. So what happened, you see Al-Arabiya in English, and the translation from speech to speech is done automatically. Okay? And more than that, because we have the text, so we can search it. So, let's say you have Google, we have our own search engine, but just to make things simple, you have Google, and once you take the Arabic text, after going from speech to text, you can run Google there, so that you search for the events you are looking for. And you want to do your search in English because you are not an Arabic speaker, you just run your search from the translation of Arabic to English. So you can run your search to English, and you have mapping from Arabic to English, because when you do the translation, usually, guys, you know that there is mapping, there is what we call alignment. So you take your Arabic text and you align it to the English side, so you know what word is what, and you know what is the verb, what is the noun phrase, what is the verb phrase, so help you do the translation. And so you keep that information when you are doing your search in English to get Arabic text back. So here I am saying the Tails do video capture, because we need to capture the video from an Arabic. It's niche, so we need to take that video. We do speech to text conversion. We do translation to the foreign text to English. Information extraction. This is main detection, co-reference resolution, relation. I will come back to this information extraction part later. Then English text to speech, because we need, the text is also into processed into English, not just text. And also, more than that, we do speaker and language identification. And what I mean by speaker and language identification, so you are looking for a specific speaker. You need, imagine you say as a request, I need a talk done by Barack Obama. So if you said, I need a talk by Barack Obama, if you do just search on the text, it's hard to find it. But we can, from the speech, from the tone, from the pitch, from that, we can define the age of the speaker. So we go to the signal, 5% right away, and this he is saying. And language ID, it's the same thing actually, because every language is pronounced differently and the same dialect. So في فلسطين, dialect is different from the dialect في Tunis, and because of that, from the signal, from the pitch, from the tonation, can know with the probability, of course, if it is Tunisian or Palestinian or Jordanian or Egyptian. Okay, so and it's built on top of EEMA. EEMA is one of this thing built, because as you understand, there is many components, so you need to glue those components together. There is many black boxes. The best way to do them together is to use this infrastructure that we call EEMA, and actually it's done within IBM. It's freeware that if you have many applications working together, it helps you glue them, integrate them into one framework. This is roughly how it looks. So have a satellite. Do my slides with the satellite and the
yes.
also the web? Okay. You have the satellites that send the video. That's the Arabiya. You have also the web, because don't only want to search for T channels, you need also the web. So you crawl all that data, you do all processing, and your computer, you interact with search with the computer. And again, I talked about EEMA, which can integrate different sources of information. At this point anyway, text process Arabic, Chinese, and Spanish. We have to add more languages, but not at this point. Now, when I said real time, is usually that's we said that to customer, but because of the technology, what we do really is just 5 minutes. That minutes is all the time required to crawl the data, do all the processing needed. And because actually it's news coming, usually the customers will not notice that, because it's flow of data coming all the time. So the minutes is not a big issue, and that also help us to run speech recognition, to run machine translation, to run information extraction, to let all this information all together on time, and we can then answer without any issue. So this is what we have. So I take here, for example, of the TV channel Al Jazeera. So what we have what we call the key frame extraction. That's really the TV channel. Take the channel, the information, all that. So that usually is you see the satellite per se, and the blend and the box you have to cache that TV satellite, and you try to save it into this channel. Then you will detect. It's very important to detect if it's a speech or non-speech, because you don't want your speech recognition is already a very hard problem. So you try to recognize speech in a space where it's, let's say, lyrics, or it's not really speech, it's something else, it's noise. You don't want to do that. So once you recognize the speech, you do a speech segmentation. You want to do that because actually what we do in the speech, it's a signal. You need to cut it into 30 milliseconds windows, and because when you do 30 minutes, I don't know that if you did speech signal processing, but that's the way, because it's a signal. You need to cut it into chunks, into windows, and extract feature from that windows. So we extract, for example, what we call the MFCC, and then we run on top of that what we call hidden Markov model. So it's a statistical approach to help you do the recognition later on. Okay. So after that, we do speech to text. So we take the speech and we make it text. In this case, Arabic. We also name entity detection. I'll come back to that. And then we do the translation of these name entities. That's important because actually I don't really want, especially in Arabic, you know, how the way we name people is a challenging actually for the language because we name with proper names. So my case is Imed. Case you have, for example, Warda or Mila or Zahra. We call later. So they have many. You know, there is many. It's different. Name in Arabic they are different. So once you know that it's a person name, you want to translate it. What you don't, you want to keep it in your translation. You don't want Jamila to become beautiful. You want to keep it Jamila. You want Warda to become flower. You want to keep it Warda because it's the person of a name. The same for Imed and so on and so forth. So once you recognize that those are people names, you want to keep them, okay? So after that, once you have this, so the next step will be to do machine translation and then index that. Then you will be able to do your search. So our search engine, we call it Omnify, but something, you know, similar to Yahoo or Google or Bing on that method, right? I will skip this. This is then how the infrastructure of Tail. I will skip it. And here I show how really Tail looks. I wanted to show it in the video, but unfortunately, that's not a possibility. So this is the rack. This is really physical. This is what we have in the lab. Okay, this is Tails. In the top, here it's what the satellite receives. So that's capture of the video coming in. Okay, and then in the middle, actually we do the speech to text. We do the machine translation, we do the unified search engine, we do the content storage, and we do the web app server. So all the engines we are naming, the speech recognition, blah, 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 these black boxes are actually here in the middle box. So you will have many machines, and every machine, many computers, and every computer is doing its own stuff. In some part, really for power and for storage, hard disks. So where you save the media, where you make sure that, you know, if there is batteries in the case of there is a shortage of power, so the batteries will work instead of the power, and something like that, electricity and things like that. So this is how Tails is. This is what I want to show in the video, but I'll give a snapshot here. Do you see this picture, guys? There. Okay. So actually, initially, the text was Arabic, okay? And text was taken from Al-Arabiya, as it shows here. It's Al-Arabiya News, okay? And it's talk. It's a talk by this Iranian politician, and here you see the M here in yellow. We are saying, oh, this is a male, okay, and this male, and that's actually he was, you know, his talk was not in Iranian because there is someone who is speaking Arabic. It was in Arabiya, so there is someone who is, you know, translating what he said, and we are translating that Arabic into English here automatically. So we are saying many waiting for less serious condition, and so on and so forth. And here, that's one shot of what is happening in Arabic. Here, in the upper left side, you have these different channels from actually all these, from CNN, from all these channels, and we have a summary. So we do a summary of what they said, and also we highlight. So see, for example, what here in yellow is organization. Also, you have in red, you have here election in red. So what that means that and so you have here what we call the name entities, and we will talk about that later on. So usually how Tails works, you put the time frame here, you put your search, what you are looking for. Here we are looking. Sorry, go back. Here I'm looking for an election in Iran, and for Iran I get a bunch of media talking about the election in Iran. Even though these media they are in Arabic, I still see the translation in English, and for a non-Arabic speaker can see what is happening in big media like here Al Arabiya, like here CNN, and so on and so forth. Okay. Now, what you here also, this is the translation part. Okay. So this is now happening at Google as well, right? So you can take the page that is in Arabic, and the page is translated right away into English, so you can read its corresponding into English. Okay, and that will help you, even though you don't understand Arabic, you can crawl Arabic media and read content of that. So this is another example of Tails, where you have the different languages that we manage. So we see Arabic, we see Chinese, we see Spanish, English, of course. And if you select on any, so these are windows, you know, this is like 2 minutes here, 2 minutes there. And every 2 minutes window, it's a video. Respond to something like this, where you can see the video as well as the translation of that speech into English. Here, entity part that I want to focus on today because it's all challenging. So here, as an example, we focus on recognizing organization, location, person, geopolitical entity, facilities, and we have a text that we highlighted with all that information. Okay, so when here I have his actually is a person, he is a person, people is a person, I is a person. It's not only the named person, it's also pronominal and nominal. I'm interested only on, in this case, Mark Sanford. Also, I am interested in a pronoun like president. I'm interested in nominal like he, like she, like stuff like that. Also recognize like here Argentina, Colombia. Also recognize organizations like here Republican Party, newspaper, and so on and so forth. Okay. Actually, I will talk in details more about this task because I find it very challenging, and in the core of Arabic NLP, it helps you understand the text automatically. So just taking a signal and converting it. So that's why. So this is, as I said, this is the part that I want to focus on: how to recognize these colors, how to recognize this name entity, and one example of that is what we call ACE, automatic content extraction, is related to the content. Question, guys, so far?
Good, I
Okay.
think everybody okay so far.
And let's see, what is information extraction? What we mean by information extraction? I mean, the idea is to understand the text, but we want what we mean by understanding the text. So you have a text like this. Okay, you have American Medical Association voted yesterday to install the referent as its president-elect, and so on and so forth, okay? So, I hear a noise. Is that no?
We hear anything. It's
Okay, so it's on my side. Okay, that's fine. Okay. So here I need to know that American Medical Association is an organization. Actually, that's why I underline it here. So to know that, I need to know that it's an organization. Also to know that AIR here refers to a person. I need to know that it also refers to what we call a mention. I'm going to introduce the term mention. Mention means actually an object that refers to a person, organization, a city, all that. I know that president is also a mention in a sense because the president refers to a person, all right? District as well, it's a location. Doctor, it's a person. Nation, same thing, and so forth, right? So once I know, and here actually I put the actual picture to these guys. So the EEMA is organization name, and Reardon is the person is a person name. Now, in addition to that, here whatever is red, what show with red refers actually to the person itself, and whatever is in the blue refers to the organization. Okay, so actually I need also to know that these are linked together. I need to know that American Medical Association and its, both of them, they refer to the same organization that is EEMA, the same group. I need to know that chairman and Thomas R. Reardon, they are the same person, because that will help me know that Thomas is actually the chairman of this organization. So you see, guys, the fact that I recognize the mentions, group them into entity. Grouping them into entity, meaning here I group Thomas, chairman, him, this chairman. I group all of them into one box, and I say, oh, this is the box of a person name of a guy named Reardon. So that's what we call entities, and to do that we do concurrence resolution. Okay, and that's the red part. The blue part, group American S group. To be in another box, and we call that also, it's another entity that it refers to the organization EEMA. Okay, this is clear because actually all my talk will be based on these two definitions of mention and entity. So it is recognizing the instance of that object, and entity is grouping them together into one that, you know, as you can imagine, once you have this information, then if I am looking for who is the man of this organization, use this link will help. And if I am looking, I'll give you a nice example. If I said Barack Obama is the president of the United States, he lives in the White House. And you know that he is pronominal, and he is linked to president, and the president is linked to Barack Obama. Then from this you can make you can make the assumption that Barack Obama lives in the White House, even though in the text don't have Barack Obama lives in the White House. In the text I have Barack Obama, President of the United States. In a document you have he lives in the White House, but I know that he refers to Barack Obama. If I know that he refers to Barack Obama, I can make the assumption that Barack Obama lives in the White House. That's how we understand the text from these mentions and entities together. Okay, and in our case anyway, we are interested in person, organization, location, facility, geopolitical entity, vehicles, and weapons. Those are the, you know, you need always the specific category of mention. You cannot recognize everything. For example, if you are not interested in recognizing animals, why you want to detect that? So it becomes application specific. In our application, this is the types that we are interested in. Right. Now, how how we do that. Let's do a little bit of math. So it's a tagging problem, okay? So similar to part of speech tagging or parsing, I don't know, or chunking, if you did that, guys. So the idea is I have a little noise here. You hear me fine there?
Yeah.
Okay. Okay. So the idea here is, did you guys do part of speech tagging and chunking? Do you have an idea about how we do part of speech tagging?
A little. If you can give us like a quick background, just to make sure everybody understands, please.
Okay. So what I mean by part of speech tagging, let's assume that you have a text, okay, and you need to know what is the verb in that text. What is, if you take every word, if this word is a verb, is this word a noun, is this word is an adjective, is this word is an article, okay. So the way you actually, if you see what we are doing publication, right? We have a word, and for that word we want to give it a class. We need to give it a label, and the label is verb, or is article, or is adverb, or is adjective. Okay, so it's right. Well, that's what we call classification. You take a unit. In this case, the unit is the word, and for unit you need to give it a label and do classification. Okay, so same thing. So in part of speech is easier because the word can be, word verb. When you name entity in this case, it's a little bit more challenging because give you a person name that is more than one word. If you Muhammad Atiyah Abdul Rahman, okay, so you have Muhammad. You take the word Muhammad and you want to give it a label. What I say? You said, okay, this is per name. Okay, you take Atiyah. If you are going to say this is a person name as well, then I understand that Muhammad is one person and Atiyah is another person. And good, because what I need to know really is Muhammad Atiyah Abdul Rahman is one person. I don't know that Muhammad is a person, Atiyah is a person, Abdul Rahman is and Abd is a person, and Rahman is a person. So all these together is a person, because if I separate them, it may have different meanings. Okay, so that is different from part of speech tagging because it's not one word, one tag. It's more chunking. It's a set of words, consecutive words, one tag. So that's why actually in the community what we call in begin inside. So we take and we said, is this the begin of a person? And it will be the begin of a person because we started there. And then if it's Atiyah, which is the second one, this is inside the person. That means that it is part of a person that we started already. We start Muhammad, and then when we get to Atiyah, we said we are still within that person. We didn't go to another word, so we're still within. Until you get to the end, you get to Rahman, it's always begin of a person, and then when you go to the after it, for example, Dhahaba, in that case it's gonna be verb. So know that that's not a name anymore. So we formulate our classification problem. I'll hear an example English. I'm getting to Arabic. I just want to understand well. English is easier than Arabic when processing. We'll see when I start showing examples in Arabic and we need to deal with the morphology. You have a language with very high morphology. When you have akaltuha, that's the person, and akaltu is not, and akala is not a person name. So you need to separate them. I'll get to that. It has a high morphology, so it has a space. We are going to use the same technology, but we need to do some work, for people work. I'll get to that in a minute. You see, how much time do we still have?
Maybe around 20 minutes.
Okay.
That's fine.
I can. I will try. I may take another 5 to 10 minutes if that's not an issue.
No,
okay.
no, it's not.
And what we used to do this, we use what we call maximum entropy problem. Okay. So here, think about it this way: you have x1 to n, and sequence of that's the word, that's your sentence. Okay. And y sub 1 to n, that's the labels that you are going to give to your sentence. And where you do that, it's product probabilities of product that label, even what you attributed already as labels, the sentence itself. Because the history of labels can be very large. Imagine a sentence of 20 words and you want word number 9. You need to take into account the previous 9 tags, labels. So sometimes it's get very hard to compute that, very sparse. So usually people get only the N, the K previous labels instead of all the previous labels. So that's how hidden lack of model works. That's how many of those techniques work. Now, I did mention the case of Arabic, and here I give you another here an example with the text and with a challenge related to it. So if we take here an example of a country which is Biladiha, okay? In Biladiha, it has kind of the meaning of her country. Here, one word has 2 mentions. One word has 2 entities. Has the entity country, entity, and it has the country person, which is the ha. Okay. The same thing for Tamidiha. The same thing for Sayyaratiha. You have the car, so you need to detect that home refers to person, and Sayyara is the car. So you see, in English it's easier because you have one word, one label. Word, one label. In Arabic, you may have one word, many labels. So you deal with this differently because usually you have one unit and you want to give a label to that unit, and hard in Arabic. And actually, I always show this example, especially to people that are not Arabic speakers, and see how hard it is Arabic compared to English. So I'm taking an English sentence and its translation to Arabic. And the PhD Abdul Nabi Saruh, a professor in Abdul Malik Said University in Tangier. Okay, its translation to Arabic. Let's imagine, guys, that in Arabic we don't write the vowels, right? Usually when you write Arabic. So if I take that English text and they remove the vowels, look guys what I get. Oh, as that same sentence is, it's more confusing, right, without the vowels. Now, we also have capital letters in Arabic. So if I take that same English sentence, I remove the capital letters. Look to what I get. Because usually in English, those capital letters have that this is a big, this is a person name, or this is an organization. In Arabic, we don't have that. So it's like look to the professor, for example, that it becomes PRFSSR, right? Now, another issue we have, right? So it's pronouns that they get glued together, okay? So like the doctor, the PhD, it becomes PhD, right? So we have this issue of morphology. It gets complicated, right? So it's really Arabic. It's harder than other languages, especially for automatic processing. Okay? So this is usually a good example. I said, look, if I take an English sentence like here the PhD Abdel Nabi Sarouk, I write it in Arabic, I get something like this, okay? And I need to process a text like this. So how to do that? Right? So usually, because there is a data sparseness, okay, so to segment this, okay, we need to separate that one word into more, and there is many ways to separate them. So this سيعلمه, will teach him. So separate the wa only. You can separate the wa and the sa, because that sa gives the future marker. You also separate the ha. Okay. So what is the nice morphological separation that will help us do good action extraction? Okay. So many ways. There is people at the character level. You can assume that you make Arabic character at the time, which means they do that. The morphological segmentation is really separating the ta and the ha and everything, and there is the ATB segmentation that is use Arabic tree bank and many others, or keep the words. Okay, usually and we do the morphological segmentation because that gives you much more information and it helps to detect those pronouns and what they mean. Okay, so if we do the first step, we text like here, segment it into morphemes, and we use the finite state transducer. Okay, so to the information, and at every point it decides I split here, I don't split here, and so on and so forth. Okay. Now, if I do that, then it is easier. Like here, when I have a Ainta refers to a person name, which is a feminine, and I know that because I was able to separate that from Iqta, so I have Iqtaraha and the Ta, the feminine, and now I am able to detect that. And if a longer chunk, like Al-Wilayat Al-Muttahida, that's fine, because as I said, L is begin of an organization, then I am inside an organization, until I get to the end. And then we conduct this name entity Arabic. Okay. Because there is many things to detect, so we do it on cascade way. So we recognize, as I said, the person name and geopolitical entity. Then once I know that, I try to detect if it's named or nominal automatically, and then try to detect if it's individual or nation. Okay. I try to detect if it's specific or generic, and also the role. Like here, Saddam Hussein is on trial in Iraq. Iraq, even though it's a country, it also has you can see it as a location or as organization. It depends on the context. So I will. This is to give you a number of the performance we have. We have almost 83 F measures. So we are still making errors, but we are to make it harder to the errors we are making. We are kind of almost 15% error rate right now, working on. We put many information to detect this, right? So we put the word, its context, we use the part of speech as an information, we use the output of other classifiers. So these are information that we use to help us do our classification, because the approaches we use are statistical. So we have a large amount of data, we learn from it, and during decoding we try to apply that. One important thing that I want to mention, it may take 5 minutes, but I think it gives an idea. So usually when I go to the community and conferences and talk to people, they will tell me, yeah, in English there is many resources, in Arabic we don't have sources. If you have resources similar to English, it will be the performance that people in English have, and so on and so forth. And they are telling usually you can find a way to beat that. We worked on that trend at IBM, and the idea, we have a lot of resources in English. How we can benefit in that to improve Arabic? You can tell me, how can you use an English text to improve Arabic text? I said, yes, we can. And I will show you here an example how we can. Even though they are two different languages, they can help each other. Okay? And here, what we do. Okay? So let's see, here we have two columns. Let's assume that in the left side, which is here, I have English. On the right side, I have Arabic. And this text is the translation of each other. There is many texts out there that they have translation. Okay, let's say if you look to in the EU, they have a lot of translation from one text to another. Again, the Arabic country, we have many websites that you have the Arabic and its translation to English. So the Arabic and its translation to English is not an issue. Okay, this is available. Now, there is also machine translation techniques available that give you the alignment. Like here, it's telling that when I do the translation, W1 is aligned to W1, W2 is aligned to W2, W5. When I do the translation, W3, W prime 3, W4 prime 4, and so on and so forth. So now I have English text in one side, my Arabic text in another side, and they are aligned. We have a lot of resources in English, okay? So I use the English model, okay? I have a very good information extraction model in English with a very good performance. I use it. I will tag my English text. I will, once I have the information in English, okay? So I will have, for example, my English text with the information I need, which is the organization, the location, the person. So I know every word, it refers to what in the English side, okay? Because the alignment, then it's easy, right? I just propagate that, I take that to the Arabic side. So my Arabic text with labels I want, but I got those labels from English. Now I have that information where I get my Arabic text with labels. So now, even though I don't have, let's say, I don't have enough data, I don't have a good system in Arabic, I can benefit from English one to propagate the information to the Arabic side. Okay, and I can, of course, do my parsing. I can generate features and so on and so forth. And I have performance. So if I have all the resources I have in Arabic, I have a performance of 75. Let's say here, if this propagation, my performance goes to 77. And this is for free because the translation is available, alignment is available, and I have resources I need in the English side. So I am managing this between Arabic and English, but can be applied by any other language. What I mean by other languages, specifically now, we need to target two dialects. So usually we don't have enough data in dialects. Let's say in the Palestinian dialect, and I am sure that in north of Palestine the dialect is a little bit different from the south of Palestine, and so on and so forth. So, and we have many texts in Arabic, modern standard Arabic. Some can think how we can, as a research idea, how we can use modern standard Arabic to recognize and to extract information automatically from dialect, from Egyptian dialect, for example, from Tunisian dialect, from dialect spoken in the Middle East, and so on and so forth. And because there is no much resources in dialect, so the idea is the information we have in modern standard Arabic can help. Okay. So I did talk about how we segment the text. I did talk about my detection, and briefly in the next 5 minutes I will mention how we group those mentions together into entity. Okay. So what I want by entity? Here I describe the problem. Take the text I showed before. Okay, I have in green I have organization, and in red, orange I have person, and I group them together. So I did recognize the mention. That's what I did talk about before. So I got the EEMA, its doctor, and I want to group them. So now that EEMA, its and the group refers to the same thing. So that would be one entity. I know that A as a president refers to the same thing. That's the second one, and doctor as well. Okay? Do that. The first mention that here is a medical association, okay? And it's a statistical approach, right? So I think an entity here is A. And I have two options. The first option is put in the same box with AMA, or to create another one. So I will have two entities, one AMA and one AIR. And it has its own probability, right? So here you have the probability to link them together, to group them together. That's the yellow arrow. The purple arrow is to say, no, they're separate. They refer to two things. And you have probability for that. And you keep doing that for the S as well, right? So either you grouped with before or it creates its own, okay? And so how that you do that using maximum entropy. So try to estimate to compute the likelihood of that based on a large amount of data. You compute events, and then that data will help you make a decision. Right? Probably to start a model, and using statistics, you can estimate whether to do this or that. Okay, and all is used based on the maximum entropy model. And the advantage of maximum entropy, it helps you integrate many features that will help boost the performance. In the case we use lexical features, we use distance features, we use the type mention, and we use some syntax. You have a parser, you have this morphological information, and you need to take advantage of it, right? An example of syntax information is the binding tree, is the Hawk's distance, is the dependency features. All of these are taken from computational linguistics. And what I am trying to say here, the field of natural language processing is really, and it's not an engineering field, and it's not a linguistic field. It's the combination of both. Combine these two both. If you have someone that knows linguistics and knows how to use computer and statistics to write programs, now you can find a successful person doing NLP. Give an example of the binding theory, for example. Okay, when you have John believes himself to be the best, only day himself gets a link. Okay. Performance. I still have 2 minutes.
No, it's okay. We can.
So here I show that what I show the performance, how it improves Arabic. As you see here, but it has more effect. Those syntax, they have more effects on Arabic than any other language, than Chinese and English. The reason for that, Arabic is a language of high morphology. It has more changes than any other language. It's easy because it's characters. Everything is character. So from characters. In English, there is this idea of words and they are separated. In Arabic, we have the pronoun attached to the word, we have the article attached to the noun. So that it becomes a challenge. And we see here that using the syntax information as statistics gives a boost. Okay. Here also I show improving using this language propagation from English to Arabic, so that you benefit from one language to help you improve the performance of another one. And this is a kind of summary of the numbers we have so far, and that's about it. So this is the building of IBM research in New York, and you are welcome to visit at any time. And thank you so much. Have any question?
Thank you very much, Dr. Imed. Actually, you talk about really, especially to put all Arabic natural language processing components to work together in a full cycle. Actually, I ask students if they have questions. The question, the accuracy, because you mentioned about 77%.
Yeah.
Go the full cycle from Arabic speech to English speech. Person.
The 77% is to recognize if this is if you have a text and you want to recognize this is a person organization. So what is in a text that is Arabic? What is the performance to know that this is a person name, this is an organization, this is a facility, and especially why the number actually, if we look only to the named person, if we look to a name list.
Is there like a measurement, evaluation, accuracy, how to go about going from Arabic TV to English speech? I mean, because there is a lot of components and are not good and
correct. Yes. So the overall performance is in the 80 range, but it's 80%. But I need to make it clear a little bit. Percent errors is not a big deal because you really what you are interested in is not all the news. You are interested in a specific part. If your answer, a paragraph you are interested in, you get meaning there, we call it success. So 80% is 80% if the translation is perfect, if everything is perfect. Actually, even if a model has a 70%, it doesn't mean that the next model will have a lower performance because they need to help. I'll give you an example. Okay, a name entity performance is 70%. It doesn't mean that the translation will be worse than 70%. The translation can be almost 90%. The reason for that is I am helping the machine translation to translate properly this person name. Bring him, this is a person name. By telling him nothing, maybe the machine translation can do the job as telling him that's a person name. Right?
This means that nothing, if you say the accuracy is 80%, nothing is actually worse than 80%, right?
No, that's not absolutely. No, that's not true because actually this is not my work. This is a study happened at ITT in 80. We're saying if the recognition system has a performance of 70%, that's enough to understand.
Okay.
So if goal is understanding, it's fine. If you are looking to a perfect transcription, all that together, then I agree with you. It's gonna be worse. In that case, if you look to that, we are 70. Okay, but it's in case where you are assuming everything is perfect.
A question, Imed, about the entity recognition.
Yes.
Do you build like an entity server, for example, to say if someone said Mr. Dant and then another one said Barack Obama, that they are talking about the same entity?
Correct. We do that. Yes. So actually. So there is a server that whatever text is that, they go through that server. It will recognize those person names, the he, the she, and it will link them together. So it will find the president, Barack Obama, he, and will tell you that he, Barack Obama, and president, they are the same.
This data set or the entities are open, at least the Arabic entities, different billings of presidents, billings of and so on. Is it open or is it private?
Come back. I will check with the management. Even if the one at IBM is not open, I can point you to something that is open because is many facilities organizations that they are working on it, including including AI in Egypt, so Columbia University. So the resources, they do exist. So I can help that. If I'll check with IBM, if I can share that, I'll be happy to do so. Otherwise, I can point you to like at universities that they do have such kind of information.
Question from Mona here. She's asking why you are building this system, for what reason?
So the reason we are building this, it happens that we have customers they're interested to see what is happening in the Arabic world. Actually, I don't know if in US anyway, in many other countries, people in banks, and customer actually is a Swiss bank. So I know that many people may think that it's really used for the government, for secret services or things like that. No, the customer here is a bank, and the banks, they need to know what is happening. It helps them in their investment strategies. And we have there is people that their work is really to listen to what's happening in the news worldwide, and there is very interesting information. They make decisions, financial decisions based on that news. If there is a trouble in Iran, why market goes down right away?
Yeah.
Because you have someone saying, "Oh, there is a trouble. I will sell whatever I have, and I will hide my money, and the things gets back normal, and then I will buy again." There's no emphasis. If you are the first one to know that IBM stocks, if you are the first one to know that I made a profit this quarter before even IBM announced it to the public, you will buy IBM stocks. Okay, and when IBM announced that it made a profit, the stock will go up, so you will make a profit. So there is banks, big organizations, that they monitor the news. They know they watching, not really watching TV, but monitoring in the sense that listening to what news is it, and based on that make a decision. That's one kind of. There is the other kind of business, which is the governments as well. What I mean by government, especially embassies in many words, and they do that in all embassies in the world. That need to know what that country is speaking about your own country, for example. And as an example, the Tunisian embassy in Washington D.C. in the U.S. wants to know if there is anything in U.S. news talking about Tunisia. They need to report that. So a system like this, say the U.S. embassy in Lebanon, for example. The embassy in Lebanon, they want to know what Labia is telling about the U.S. So a system like this will help them. Though they don't understand Arabic, they will help them figure out what the Arabic channel is saying about the U.S. Another application. So it's a way to monitor news in TV channels or the web in a language that you don't understand. Many other applications. I'm only giving you two, but there is many other applications that can be used here. Actually, we use the same system here, the technology, I mean, to do speech-to-speech translation in an iPhone, in a portable device. So even that you are traveling to,
exactly,
you are traveling and you can talk to any other person just using the phone. That will do the translation for you.
That's perfect application. Okay, Dr. Aman, thank you very much for your
welcome.
And we hope actually this is the start, and we will
thank you
maybe not only on lectures, but also maybe we will invite you for a project.
Inshallah.
And we will actually we put your lecture, because it was video recorded, we put it on the website of the course for public. Do you mind about this? Okay, thank you very much. Yeah,
I'm fine. No problem.
Yeah, bye bye.
You're welcome. Take care, guys. Bye.
حضرت امبارح؟ عندها هذا الدكتور كان تيجي بس بيعطيني من الجزيرة بيترجم يعني بيترجم لا يعني بقول الفيديو بحط صوت بالإنجليزي وبحول صوت هذا بيعملوا له عمليات يعني تقدر تعمل عملية بحث والتكست وخلوه يقولوا انه مثلا مسؤول تحكي مثلا تقول صارت اليوم مثلا عملية عند المنطقة كذا وشغلان وفلان بيكتبوا عارفين وين اسم فلان وعارفين وين يعني بالنسبة للصحة من نيويورك يعني طبعا كله شغل طبعا بجوز انت لاحظت كمان سبيكر ايدنتيفيكيشن اللي هي يعرفوا انه اللي هو كانوا منطقة اكيد بعد الرجع الا الناس بجوز مشهورين بس من منطقة بيحسب لبناني هذا السوري هذا المصري اللي هي اسمحوا لي اول شيء الدكتور الاستاذ ماهر او الدكتور مهدي عراق وكل بروفيسور وعميد كلية الآداب عميد كلية او يعني هذا عربي اول مرة فيكم هذا الكمبيوتر بس بشكل الموضوع كيفاش حكى زي ما حكى الدكتور عماد الموضوع اصلا هو بده اثنين بده واحد من جهه الاي تي وواحد من جهه اللغه وعدد الناس يعني نقول شخص شيء مع بعض بما انه عاده مع نفسه بيسموا خلفيتين مرات فبنحب نرحب بالاستاذ مهدي وبعطينا محاضرتين محاضرة عامة للدراسات الإنسانيات الحاسوبية بعدين هنوقف عن مشاكل الماشين ترانزليشن طبعا الدكتور مهدي مستشار لشركات في هذا المجال فالدكتور مهدي الشباب طبعا بالنسبة للذكاء الاصطناعي المستخدم وهذه الذكاء الاصطناعي يعني الذكاء فندرس مشاكل على في الذكاء نحكي عنه طيب في أول سؤال من كثير تتعامل يعني إحنا دي في واحد يطلع يسوي كهون وبرجع هنا مش مهم كل يعني ليس سنة عربية سنة ساعة لأنه والله صح ولازم يطلع على كريم سريع عندي ما نجيب فيها
حالك الحمد لله تمام الله يسعدك كيف حالك الحمد لله وين انتي رحتي وخليتي الحمد لله لازم هذول مش مقتنع ولا بدك اياهم
لا تعطي مجالات مش سهله في العمل
بس احنا نشتغل فيها هاي
هو ما حدش يقدر يسويها، هاي أصعب شيء في التاريخ.
زي ما بتقدر تسويها. هلا حللناها أنا وهذه بخاية.
كنت السبجكت كنترول بدك تفهم كيف سوينا.
هي أنا فاهمة السيستم يعني.
أقول لك أشككك في مفاهيمك؟
لا مش فاهمة.
اشتغلت مش وظيفة حكيت لك عنها، وظيفة ثالثة.
أها.
اشتغلت في مدرسة قريبة كثير على بيتنا. ملازم. والخميس اللي نملي فكرت انك تحكي ما استوعبت ايميل انا بحكي لك اشياء شخصي
مبسوطية إنك أنت شكلك مبسوط. مبسوطة؟
يعني اصلا
شو بدك إياه؟
بدي وظيفة مريحة ومصاري كثير.
ما تشتغل.
الله يسامحك والله انا سمعت شغل اصلا.
تستنى.
هذا امبارح رائعة.
مش كل حدا خمس. يعني
لا حتى جيت يعني بديت احضر معكم على 4 إلى 10 يعني حتى زعلت راح علي الأجل.
بس معاكم
في ماضي ما حيرت الأنفق في ماضي هاي لا
المنطقة مش هتعرف. شايف أشوف وين بكل شيء هذا تكون تحول ظل الموجود هي تستمر لا هيك تسلك انت على طرف ضوء تستخدم عشان كنت